So this is section 2, topic 11. And it's called Systems of Linear Inequalities. Example 1. The entrance exam to graduate college has 2 sections. Comma, a verbal reasoning section and a quantitative reasoning section. The exam has a maximum score of 1,600 for the entire test. And maximums for each section of the test of 800. The school of your choice has a set minimum quantitative score. Of at least 625. And a total minimum score of 1,250. Write a system of inequalities Write a system of inequalities to model scores that meet the school's requirements. Bless you. Then solve the system by graphing. Okay, so we're going to need some variables here. And of course we need to define them. What do you think we need variables for? The two sections of the test, right? Because you can get different scores. A different score on the quantitative test, the quantitative reasoning section, and then the verbal reasoning section. Those scores are going to vary, so we need variables. Does one score depend on the other? In other words, do we have an independent variable here or a dependent variable? No. So if you do, remember your x is always the independent variable, your y is always the dependent variable if one's independent and one's dependent. If that's not the case, then it doesn't matter which one's x and which one's y. So, but you have to define it. So I'm going to let x equal the verbal score and let y equal the quantitative score. So some of you may have already applied to colleges, some of you will be, hopefully everyone at some point, and you'll know when you take the ACT and SAT, whatever college that you're wanting to go to, they're going to have minimum requirements, and the different tests have different ways of scoring, so you have to know what school am I going to and what do they require on each section, and then what do they require for you to earn, both sections total and all that stuff. So what we have to do is we're going to write an inequality, and it's an inequality because you can get different scores that it's not one score, right? Which would be an equation. So since there's a lot of different possibilities, we use inequalities. So first thing, let's see, it says that the exam has a maximum score of 1600 for the entire test and maximums for each section of the test of 800. So we know that 800 is the maximum you can get on each section, right? So if 800 is the maximum, then my verbal score has to be greater than, less than, greater than or equal to, less than or equal to 800. What would it be? If 800 is the maximum, it'll be less than or equal to. You can score exactly 800 or less than 800. Can't score over 800 if it's the maximum. And the quantitative score also has a maximum of 800. So it is less than or equal to 800. It also said the school of your choice has set a minimum quantitative score of at least 625. So for your quantitative score, it's got to be at least 625. So how would I write that? Greater than or equal to. So we know when we graph these, the score that we can get is going to be somewhere between 625 and 800, right? I mean, you could score lower than 625, but not to get in the school that you want. And then it also says you have a total minimum score of 1,250. So for both tests combined, you have to get at least 1,250. Anybody have any idea how we'd write? What's that? Very good. X plus y is greater than or equal to 1,250. So the verbal reasoning section plus the quantitative reasoning section has to be greater than or equal to 1,250. So we're going to put all of these inequalities on a graph and see what our possible scores are that will satisfy all of these different terms that this school has. Okay? Yes, ma'am.
Don't they also write the 625 on the other side of the y too? Like, couldn't you put 625
If you wrote the 625 first, it would have to be 625 is less than or equal to y. You can do that, but the inequality symbol needs to open up towards the y.
No, I mean on like where the 800 is. Couldn't you write 625 on the other side?
Oh, you mean like put the y in the middle and 800 on one side? Yeah. But we're going to graph them all separately so you can see on a graph, like if you graphed each one separately, which one, how it makes them all true. But yeah, you could do that. Okay? Definitely could do that. Okay, so on my next page, I know first of all that the highest score I can get is 1,250 with them combined. So I'm going to do on my X and my Y axis, I'll do increments of 100. And I'm going to go up to at least 1300. So you can start graphing that. And every one of your, whatchamacallit, bags under your chairs, what I call it, those little supply pouches should all have a ruler. Thank you. And both of mine are missing. I'll be back. There's 3 up here. Yeah. I'm sorry? Yeah. And make sure you also label each axis. The x-axis is the verbal reasoning section. And the y-axis is the quantitative reasoning section. And so remember, when you're graphing inequalities, since you can have more than one solution, unlike an equation, you have to shade the area where your solutions are. And a lot of students get confused by that. When you draw a line, you're going to make 2 areas. So pick an ordered pair in the area that you think is where you're supposed to shade. Substitute it into your inequality, and if it makes a true statement, then you know, yeah, that's the area you're supposed to shade. If it makes a false statement, then you shade the opposite area. Okay? Now we do have 4 different things to put on the same graph. So you want to be very neat about it so that you know what's going on, because we're going to have 4 different shadings to do. And I'm using 4 different colors, highlighters. You can use a pencil, But when you just use one color and you have 4 things to shade, it can be kind of confusing. You know what I mean? So in your supply pouches, you may have some colored pencils, or you may have some highlighters, or if you have different colored pens, you may have to share some stuff with your neighbor. Some of those pouches get, bless you, stuff doesn't get returned to them, and everything gets put in one pouch instead of the other. So just make do with what you have. Do the best you can. Okay, so we know that all of the verbal reasoning section has to be less than or equal to 800 because 800 is the max. So if I were to graph that and it was an equation, it would be x equals 800. What kind of line only has an x and no y? If I were to graph that, x equals 800, right, it's vertical, right? If you only have x equals some number and there's no y, that means it's a vertical line. And this vertical line is going to cross the x-axis at what, where? 800. So all of my x values that are less than or equal to 800, would that be values to the left of that line or to the right of that line? To the left. To the left, to the left. And so I shade to the left of the line because that's where all of my possible scores that are less than 800 or equal to 800 would be. Now, since the line is solid, that means 800 itself is a possibility. If the scores could not be 800 but had to be less than 800, we wouldn't have the or equal to part, and we would do a dash line. But a solid line means it also includes 800. It's like, think about the parentheses and the bracket when we're doing interval notation. It would be a bracket. I would shade it all in, but some of my yellow's going to be lighter and you won't be able to tell, so that's why I didn't make it solid color. You know what I'm saying? But the line itself is solid. That means it can equal exactly 800. And you can make it solid if you want to.
Wait, is all of this supposed to be shaded?
Everything to the left of that line is supposed to be shaded. Because any ordered pair in my shaded region would have a verbal reasoning score of 800 or less. No matter what ordered pair that I picked, even on the line, would have 800 or less. Now, this shading only makes that statement true. X is less than or equal to 800. Okay? I've got to shade all of them, and wherever everything overlaps, that's going to tell me the scores that I could get that would make everything that this school wants to happen. Okay? So, the quantitative reasoning section has to be less than or equal to 800 as well. So that, if it was an equation, that would be y equals 800. So what kind of line only has a y and no x? A horizontal line. So we're going to draw a horizontal line that goes through what on the y-axis? 800. And it's solid because it says or equal to. So would I shade above this line or below this line? Below. Because all of the y values below the line are less than 800 or equal to 800. If they're actually on the line, they are equal to 800. So anything in the orange only region only makes that top equation true. Anything in the pink only region only makes that second, I said equation, I meant inequality, that second inequality true. Anything in the pink and orange makes both of these true. But we need to know scores that make all 4 of these statements true. So we just said y has got to be less than or equal to 800, but they also said you have a minimum of 625. So it has to be greater than or equal to 625. So that's another horizontal line, but this time it's at 625. And when I shade above or below this line? Greater than. Above. It's above that line, and it's everything above, because I'm only talking about that inequality at this moment. So the region that makes all 3 of these statements true is getting smaller, right? Anything that's in yellow only makes my yellow inequality true. This region right here makes the yellow and the pink true. This makes the orange and the yellow true. Only this right here, this small region, makes all 3 true so far. Okay, x plus y is greater than or equal to 1,250. We could convert this to slope-intercept form, so we would subtract x. So we would have y is greater than or equal to negative x plus 1,250, and have a y-intercept of 1,250 and a slope of -1. Or we could just find the x and the y-intercept, which is very easy, especially in this equation. If I want to know what my x-intercept is, every ordered pair on the x-axis has a y value of 0, right? So I'd substitute in 0 for y, and what would my x-intercept be? 1,250. If I want to know where my graph crosses the y-axis, every ordered pair on the y-axis has an x value of 0. So I say when x is 0, what is y? 1,250. So that's easy, just to graph the x and the y-intercepts. Okay, you could do the slope if you want to. And it's going to be a solid line because it's the or equal to. So this line's not vertical or horizontal. So we have to graph, it says greater than or equal to. Above is greater than, but a lot of kids get confused on that. They're like, well, what's above? What's below? I don't understand. Yes, when you add them together. So say you were like, okay, well, I think it's this region down here. Well, pick an easy ordered pair to plug in, okay? So if I picked 100, 100, that's a ordered pair below that line, isn't it? Well, if I substitute in x is 100, y is 100, is it going to make this statement true? No. So that means any ordered pair below that line is not going to make the statement true. Well, let me pick an easy ordered pair here. If I picked 1,000, 1,000, right here, is that an ordered pair that's above this line? Yeah, is 1,000 plus 1,000 greater than or equal to 1,250? Yeah. So it makes that statement true. So that means any ordered pair in the region above the line would make the statement true. So I shade in the region that makes that makes this inequality true. I'm just talking about this inequality right now. So from that line, everything above it I shade. And obviously the more inequalities you have, the more confusing the graph can look, because you got a lot of different shading going on. So if you just use pencil, it's really hard to see where they overlap. Okay, so we have graphed all inequalities. Can somebody give me a test score from the verbal reasoning section and the quantitative reasoning section that I could use to get into my school of choice, giving all of these constraints? Yes, ma'am. Say it again.
750 and 750.
750 and 750. Let's see. 750. Does that look like it's in the region that everything overlaps? Yep. Is 750 less than or equal to 800 on the x-axis? Is 750 less than or equal to 800 on the y-axis? Yes. On the y-axis, is it greater than or equal to 625? Is 750 plus 750 greater than or equal to 1,250? Yes. So that makes all of them true, right? So that is a possible score. 750 verbal, 750 quantitative. I'm just going to list some possible scores. Is that the only score you could get? 800, 800? So it lies on the solid lines, so it should make both of them true. Is 800 less than or equal to 800? True statement. 800 less than or equal to 800 on the y-axis? True statement. 800 on the y-axis greater than or equal to 625? Yes. 800 plus 800 greater than or equal to 1250? Yes. Is there another option? 625 and what? 625 and 625? Let's see. Is verbal score less than or equal to 800? Yes. Quantitative less than or equal to 800? Yes. Quantitative greater than or equal to 625? Yes. Is 625 plus 625 greater than or equal to 1250? Yes. So that makes them all true. And are there plenty other scores that we could find? Yeah. So everybody sees it's this region in here. Only this little triangle is not part of the overlapping region, is it? It's just what's in this section here where your solutions are. So the other shaded regions make the other inequalities true. But you're looking for the region where all of the colors overlap, because that makes all of the inequalities true. Cool with that? And isn't it so pretty? Oh, I know. 2 more. This is the longest one.
Well, hold on, wait.
Example 2. Olivia, by doing a quick scan on my desk back there, will you look and see if you can find my navy blue pen, just see if it's laying anywhere around there? Keep losing that thing. No, I want the navy blue one. Okay, I think I lost it. Thank you. Does it write really well? It's one of these? Oh, yes, I would love that. What's that? No, I have that one. I misplaced my navy blue one, and I just bought it. I think, I don't know. Somebody told me that it will break
I
it.
have my own, I can try.
Okay, yeah. Please. I don't know if it's true, but somebody said colored pencils will break it. Thank you so much. I appreciate it. All right, example 2. Suppose you are buying 2 kinds of notebooks for school. A composition book costs $1. And a 1-inch 3-ring binder costs $3. You must have at least 6 notebooks. The cost of the notebooks can be no more than $15. Write a system of inequalities to model the situation. Okay, so could we figure out what possible combinations of notebooks we could buy without doing a graph? Yeah, of course we could. But I'm teaching you how to solve inequalities by using graphing, so that's what we're going to do. Okay, what are we going to need variables for? Yeah, how many composition books we can buy and how many binders. Does one depend on the other? No, so we don't have a dependent variable and an independent variable, right? So x can be either one of those, y can be either one, it doesn't matter, but we have to define what is what. So I let x equal the number of composition books. And I let y equal the number of 3-ring binders. And we really only have two constraints here. One, the number of books that we have to purchase, and the other, the cost of the books. So if we wrote an inequality based on the number of notebooks we need, anybody have any idea what that would be? How many notebooks do we need?
6.
And we need at least 6, right? So at least tells us it's an inequality. Bless you. So can we have 5 notebooks? No. Can we have 6 exactly? Can we have 10? Yes. So how would we write that? The number of composition books plus the number of binders, think about that, has to be at least 6. Very good. X plus y is greater than or equal to 6. Number of composition books plus number of binders has to be at least 6, so greater than or equal to 6. So that one's about the number of books. That has nothing to do with cost, so we don't put the dollar amounts there. Now it also told us we don't have any more than $15 to spend. Can we spend exactly $15? Can we spend $15.02? Can we spend $14.99? Yes. So what inequality would we write based on the cost of the books?
X plus y is less than or equal to $15.
So close. This one's about cost. Are we only buying one of each book? Or does each book only cost $1? I mean, that's what I meant to say. No. Exactly. So if this one's about the cost, we got to put the cost of each book, right? So composition books cost $1, so 1x is just x. 3-ring binders were $3, so $3 times each composition book, and that has to be less than or equal to $15. Okay, so to graph these, and I know that we could probably graph them without showing our work, but this is my notes. And if you look back in your notes and you still can't remember how to graph a line, I'm going to remind you. Now remember, these are both in standard form. So I could convert them to slope-intercept form. I could do that. Find the slope and the y-intercept. Or I could just find the x and the y intercept. And to me, these look like they're going to be pretty easy to find the x and the y intercept. Okay, so that's what I'm going to do. Or you can make a table of values, but I want y'all to be able to graph without making a table of values, especially if it's just a line. So to graph the equations, we can either convert to slope-intercept form, or we can find the x and y intercepts and graph that way. I'm choosing to find the intercepts. So I've got to find the x and the y intercept for each graph. So I'm going to take each inequality, and actually I'm going to write them as equation just because I'm finding the intercepts. But I'm going to write each one twice as an equation, because I have to find the x-intercept and the y-intercept on each graph. Oh, that's not what I meant to write.
What are you using the first for right here?
What did it was I what?
For the colors.
I used purple and blue. Because when I graph, I'm going to graph this line, I'll use a purple and I'll shade purple, and this line I'll use my blue and I'll shade blue. So I just color coordinate. You know I like to color coordinate. Okay, so if I want to find the x-intercept, we know every ordered pair on the y-axis will be 0 if I find a point on the x-axis. So that means we say when y is 0, what is x? X will be 6. So the x-intercept on my first line is 6. What did I do here? I made a mistake again. I meant to also write x plus y equals 6 the second time. I'm sorry, especially on video. And so I'm finding the x and y intercept of each line. So same line, I want to know my y-intercept. So every ordered pair on the y-axis has an x value of 0. So I say when x is 0, what is y? Well, in this case, my y-intercept is also 6. Remember Darnell from the video, he would just put his finger over the y value and find x, or put his finger over the x to find y. That's what he was doing to find intercepts. Okay? So on this one, if I did that, what's my x-intercept going to be on the other line? 15. What would my y-intercept be? 5. But I'm going to do my math. So x-intercept, substitute in a 0 for y, and solve for x. Y-intercept, substitute in a 0 for x, and solve for y. We good? Alright, so I'm going to go to my graph paper, and I'm going to graph both lines, and I'm going to shade where I'm supposed to shade. And I know my highest x value is 15, so I've got to go to at least 15 on the x-axis, and on the y-axis I have to go to at least 6. So I'll go to at least 15 on both axes, and I'm going to do increments of 1. I said to at least 15, and I'll probably go higher than that. So my first inequality was x plus y is less than or equal to 6. And for that one, we had an x-intercept of 6 and a y-intercept of 6. So my x-axis, plot a point at 6, and my y-axis, plot a point at 6. And it was greater than or equal to, so that means solid line. If it was just greater than and didn't have the or equal to part, we would use a dashed line. And to satisfy this inequality, all of my solutions have to be greater than or equal to 6. So if I chose an ordered pair of 2, 2, is 2 plus 2 greater than or equal to 6? No, so that means if I chose 3, 1, is 3 plus 1 greater than or equal to 6? No, so that means any ordered pair below this line is not going to satisfy. Well, let's just pick 10, 10. Is 10 plus 10 greater than or equal to 6? True statement, right? So that means that ordered pair lies in the region that has the solution. So I shade above. Greater than means above. But again, if you're not sure which part of the line is above the line, pick ordered pairs, substitute them into your inequality, and see which side of the line make the inequality true. Okay. My other inequality was about the cost of the books. The number of composition books for $1 each and $3 for each 3-ring binder had to be less than or equal to $15. For that one, we found that our x-intercept was 15, our y-intercept was 5. So if we bought 15 composition books, we could buy 0 3-ring binders. If we bought 5 3-ring binders, we would buy 0 composition books. And that was a less than or equal to, so because of the equal to part, it's a solid line. Less than or equal to, less than means below. So I'm thinking, here's my line, I'm thinking below it would be down here, right? So let me just pick an ordered pair that's below. Let's pick 7 composition books and 1 binder. That would be $7 for the composition books, $3 for the binder would be $10. Is that less than or equal to 15? Yes. So everything below the blue line makes only my blue inequality, the one about costs. If it's only in the blue region, it only makes the cost inequality true. If it's only in the purple region, it only makes the number of notebooks true. If it's in purple and blue, it satisfies both inequalities and it will give me possible combinations. So can you see the region where everything's overlapping? Yeah. Give me some possibilities. 8 composition books and 2 ring binders. Do I have at least 6 books? No, and 8 composition books would cost me $8. 2 3-ring binders would cost me $6, so that would be $14, right? Do I have enough money for that? Yep, I have $15. 8 comp books and 2 3-ring binders. 2 composition books and 4. That's real close, so let's check our math. 2 and 4, that makes 6 books, and I need to have at least 6, right? 2 composition books would be $2. 4 3-ring binders would be $12, so 14 bucks, I have enough money, right? So that works. 2 composition books and 4 3-ring binders. Could I do 15 composition books and no 3-ring binders? Yep. It didn't say we had to have both, right? Or can I do 5 composition books and no 3-ring binders?
No,
Right. Can I do, because I meant to say, 5 3-ring binders and no composition books?
no,
Still not 6. Could I do 6 composition books and no 3-ring binders? What's that? Too much money? Oh yeah, 6 composition books, no 3-ring binders. Yeah, that'd be $6, right? So 6 composition books could I do 6 binders and no composition books? Could I do 5 binders and no composition books? I gotta have at least 6, right? Are there other combinations that we did not list? Yeah, there's all sorts of combinations in that shaded, the overlapping region that we could use, right? We just picked a couple. So as long as they make all of our constraints true, did I say restraints earlier? I hope not. I hope I said constraints. All our constraints true, then we're good to go. All right, one more coming at you. Anybody have a question about this? My giant graph. Okay. Example 3. I have more graph paper up here if you need it. Now, I don't know how to say the name of this campground, so I'm going to try my best. I'll show you how it's spelled. I'm going to go with Chihuahua. Does that sound good? Chihuahua Campground. Anybody heard of it before? Can tell me the actual pronunciation? Okay, then we'll go with Chihuahua. Chihuahua Campgrounds provides mountain hikes. Period. A camp counselor can take no more than 30 campers on 2 mountain hikes per day. Each day there is a low trail and a high trail hike. The counselor must have a minimum of 10 campers on the low trail and a minimum of 5 campers on the high trail. Write a system of inequalities to model the situation. So it's always a good idea to read word problems at least 2 times, right? If not more. Chihuahua Campgrounds provides mountain hikes. A camp counselor can take no more than 30 campers on 2 mountain hikes per day. The 2 mountain hikes comes from, there's one low trail hike, one high trail hike. So together, no more than 30 campers per day, right? Each day there is a low trail and a high trail hike. The counselor must have a minimum of 10 campers on the low trail and a minimum of 5 campers on the high trail. So no more than 30 campers a day, but you got to take at least 10 on the low trail and at least 5 on the high trail. Okay, so what are we going to need variables for? Exactly. One of the variables has to be the number of campers on the low trail hike, and the other one's got to be the number of campers on the high trail hike. Is one dependent and one independent? No, so does it matter which one's X, which one's Y? Nope, but we have to define it. So I let X equal the number of hikers on the low trail. And I let Y equal the number of hikers on the high trail. So let's talk about altogether there has to be no more than 30 campers. Anybody know an inequality we could write to represent that information? Ashanti.
Y is less than or 32.
Say it,
Or
say it again.
X plus Y is less than or equal to 30.
Very good. X plus Y is less than or equal to 30. Does that make sense? Number of hikers on the low trail plus the number of hikers on the high trail has to be less than 30 or equal to 30. Makes sense, right? One of the other constraints was that you must have a minimum of 10 campers on the low trail. If X is the number of campers on the low trail, how could we write that? Greater than or equal to, because it's a minimum of 10. So 10 is the lowest, right? So your number of hikers on the low trail has to be greater than or equal to 10. We know it can't be more than 30. But remember, we're writing these all out separately. And a minimum of 5 campers on the high trail. Very good. So, on that top inequality, what's my x-intercept going to be? 30. What's my y-intercept going to be? Do we need to do the math to figure that out? No, that's an easy one. So on my graph, and that's all we have to do, we just have to graph it and see how, I can't talk today. Find different combinations that will make all 3 of our inequalities true, okay, our constraints. So I'm going to do increments of 5 on each axis. Do you have to do the same thing as me? No, but I know if I have to go up to 30 on each axis, I don't want to do 10 because it won't be very precise, you know, so I'm going to do 5. If we want to make it really big, we could do 1, but... So x plus y is less than or equal to 30. We said our y-intercept is 30 and our x-intercept is 30. And it's going to be a solid line. We haven't had any dash lines yet. Solid means any ordered pair on the line will satisfy the inequality. And my hikers added together have to be less than or equal to 30. Do you think that is the region above the line or below the line? Less than's below, right? So that should be true. If I had 10 on the low trail and 10 on the high trail, would that be less than or equal to 30? Yeah, so that makes a true statement. and it falls in the region below the line. And we had a minimum of 10 hikers on the low trail. So we used x is greater than or equal to 10 to represent that information. If that was x equals 10, what kind of line would that be? Vertical line, and it would go through 10 on the x-axis, and it is solid. Solid. Would I shade to the left or to the right of that? Where are my solutions less than or equal to 10 as far as the number of hikers on the low trail go? Greater than or equal to, I'm sorry, I said less than. Greater than or equal to 10 would be to the right. So this line, everything to the right of it, because every ordered pair to the right has an x value greater than 10. On the line is equal to 10. But I could not have 50 low trail hikers and 30 high trail hikers. I could to make this inequality true, but not the whole problem. Okay? And there had to be a minimum of 5 campers on the high trail. So that inequality was y is greater than or equal to 5. What kind of line would that be? Horizontal, and it would cross the x-axis when y equals 5. And would I shade above that line or below that line? Above it, because every y value below that line is not greater than or equal to 5. Bless you. Bless you. You're welcome. Can anybody give me a possible combination of hikers that would make all 3 inequalities true? 15 hikers on the low trail and 15 hikers on the high trail. Would that be less than or equal to 30? Yes. Would that be at least 10 hikers on the low trail and at least 5 hikers on the Y trail? Yes, so that works. 15 low trail, 15 high trail. Now, if that was a dash line and that ordered pair falls right on the line, then that would not work. Because that means it would be like less than, not less than or equal to. You know what I'm saying? So dashed means it's like the boundary line, but an ordered pair on that line is not true. But since it's solid, it does work. Another combination. 15 and 10. 15 low trail hikers plus 10 high trail hikers. Is that less than or equal to 30 hikers? Yes. Do we have at least 10 on the low trail? Do we have at least 5 on the high trail? Yep, so that works. 15 low trail, 10 high trail. Could I have like 11 low trail and 7 high trail? Yeah. That would make all 3 inequalities true as well. Constraints. Could I have 12 and a half low trail and 7.6 high trail? Right. It doesn't make sense to the problem. That's an ordered pair that's in that shaded overlapping region, but it doesn't make sense to the problem, right? Yeah. Okay. So, y'all cool with this? Anybody have any questions? Okay.
got the one tonight, I'll bring